Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I am Julie Tomei, and I am joined by Dr. Elena Hyde. Hi, Elena.
Hello, hello. Happy to be here.
We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night from 9 p.m. local Toronto time or Tuesday morning, 1 a.m. Universal Coordinated Time on YouTube at York U Observatory in concert with our online public viewing program run by the Observatory team. To navigate to the live show or find out more, check out our website at www.yorku.ca/science/observatory and follow the links to OPV for online public viewing. You can join the live chat on YouTube. For any questions or comments you have of our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on socials. On Instagram, our handle is at YorkU Observatory. We are on PixelFed at Allan I. Carswell Observatory and on Facebook at Allan I. Carswell OBS. All of our programs are free, but if you would like to make a donation, we will gladly accept it. Just head over to the website. Again, that is yorku.ca/science/observatory. We'll be monitoring the chat room for questions and to post content. Sadly, the current weather is cloudy, so there will be no live telescope views this evening. But we will have lots of lovely archival images from the observatory team. How are you doing, Elena?
Oh, pretty good. Yeah, just watching those clouds roll through. They're saying now thunderstorms and rain all day tomorrow. So it's a little bit of a tough time to be an astronomy fan. I mean, of course, it's like, oh, if only it was clear, we'd be seeing Venus stats and a beautiful moon out there, nice crescent moon. But we'll just have to fingers crossed for tomorrow maybe. It's we'll still have a slightly less crescent moon, but um, Venus will still be there just after sunset, and there's some hope for catching some cool objects still, even with the very, I have to say, bouncy weather we've been getting. Sort of okay, and then high wind, and then thunderstorm. There was talk of a tornado last weekend, so.
Yeah, it has been a little weird. Um, I'm willing to say at least part of that is because of all the smoke.
Yeah, there's a lot of large differences in air temperature running around, which definitely does not help the weather or the seeing.
Yes. Well, at least the sky isn't orange, post-apocalyptic orange anymore.
I'll take it.
There will be clear nights again.
And we do have some fingers crossed for tomorrow. And I have to say, yesterday was actually excellent. We had some very, very good seeing. So yeah, it's not bad every night, just maybe not great tonight.
Yeah, can't rain all the time, or so I
I
heard.
mean, not so far, but don't jinx it.
All right, Elena. How would you like to get us started with uh
Well, history. Let's do some
yeah,
history, and then
let's do it.
let's talk about some fun updates and do some news items. There's a lot going on always. But I thought it would be a nice time to kind of remember um, when space travel was popular. And this is lunar travel. So if I go to July 24th, which is just in just a few days, and I go back to 1969, which by all accounts was also a very strange time. But this was Apollo 11. This was the first humans on the moon. And of course, it was. a very interesting program in so many ways because you had from Apollo 11 to Apollo 17, a series of lunar landings, human persons on the moon, which had, to our knowledge, despite some not so scientific talk I've seen on the social media, it's never been done before and has never been done since. And this is one of those things that is an amazing first. And it's really interesting to see, of course, how the program got up and running so quickly, how they got humans to the moon, how they built it out, and then once it ended in with Apollo 17 in 1972. So this is the 1970s. This is quite a while ago, as many people like to point out. We have never put humans back on the moon. No human feet have been on the moon since then, and it's a really interesting time. So I thought let's go back in time and look again at Apollo 11, that first space flight that landed humans on the moon. This was actually the fifth crewed mission from NASA's Apollo program. So this was not the first human in space by any means. Um, this was the first human to actually stand on the moon. And so, of course, I think everyone has heard or seen little clips from this throughout history, but it was a major event. Of course, the mission was crewed by Neil Armstrong, and the lunar module pilot Edwin Buzz Aldrin. Very famous names. Of course, the command module pilot Michael Collins. Um, there have been many articles written about his, of course, not getting to land on the moon, but having to be up at the lunar module. Um, but this, time period, 1969, it's very different from what we would see today. The spacesuits were very different. These early spacesuits were actually made, and this is a totally different story, which we probably should cover at some point, but there was a crack crew of seamstresses, and not just any seamstresses. They were makers of brasiers and undergarments
I
because they
have heard
needed
that.
yeah, they needed extremely sturdy construction techniques to create a suit that would not, result in the astronaut's death. And apparently there was a whole extra research project of, people talk about, hidden figures a lot, but I'm waiting for the next Hidden Figures to come out with the brassiere seamstresses who made
Hidden bra strap?
who made the spacesuits that the astronauts wore. And of course, talk about revolutions in technology. Even the spacesuits, everything was being done for the first time. And they didn't just go up with their cell phone and their GPS like we've seen in more recent times with Artemis. There were long periods where they were out of touch with Earth, and if they wanted to make changes to their trajectory, it resulted in humans having to do those calculations.
Mm-hmm.
Humans on Earth, humans in space. It was a very sort of manual labor sort of endeavor, shall I say? Rockets notwithstanding. Um, they did spend 2.5 hours walking on the lunar surface. There was a flag planted for the Americans, and and just like current day, of course, the American president trying to get involved by speaking to them over telephone. So at that point, that was Richard Nixon. Um, After about 21 hours on the lunar surface, they actually rejoined Michael Collins, who had been in lunar orbit this whole time. And they returned safely to Earth on July 24th, splashing down in the Pacific Ocean. And this first splashdown is very different, again, from what we've seen with a more recent splashdown of Artemis, where they had, large amounts of safety processes and this entire sort of float that they designed for the craft to be surrounded by. This is very, very interesting. And of course, in the 60s, the US was not just going to the moon to go to the moon. They were going to the moon because they were engaged in the Cold War with the Soviet Union. And so it was at a time of extremely heightened geopolitical emotions, and there was a lot going on. Of course, the space race was a way for those superpowers to kind of try to demonstrate their superiority. And as the U.S. made their landing with Apollo 11, and of course all the future explorations that they would go on to do, over time they kind of dominated the lunar landing scene, as it were. The U.S. being on the moon did not result in the Russians also landing on the moon. And for many, many reasons, which we probably can't go into in today's show, Apollo 17, and this was the 11th and final crewed mission, was just in 1972, and a lot of people at the time testified between at U.S. Congress and said, "Look, we have to make this sustainable if we're going to keep up the exploration in our solar system. We need to keep going, or we're going to lose the capacity to explore our own backyard." And sure enough, we did. So humans still have not been back to the moon. We've lost this capacity that we had. And at the moment, we're now trying to reinvent a lot of the things that Apollo 11 had. Like, of course, the launch vehicles being actually a quite a big one. But not just the launch vehicle, but of course, Apollo 11. Um, they had the command module and the lunar module, I should say, and the command module, and the spacecraft had a service module as well. So the command module was the only part that actually came back to Earth. The service module was the propulsion and electrical power, and the lunar module had two pieces. It could go at a descent stage, and an ascent stage, so it could go onto the moon and come off of the moon. And we don't have those anymore. So right now, it's a little bit interesting to watch what's going on with. So this is history and, I suppose, current news. But we've seen now Artemis 1 with its new launch vehicle. Of course, the Orion and the SLS, so the launch system that was newly built for this new endeavor that's starting up in 2020, well, 2025 really was when it got going. But this SLS space launch system, that is the newest heavy lift expendable launch vehicle, to send up an Orion craft. This one doesn't have any ability to land on the moon and come back off of it. So we've seen Artemis 1 and 2 go around the moon without landing on it. And I believe Artemis 3, which is still tentatively planned for 2027, which is next year, is a crewed space flight, which is basically going to stay in low Earth orbit. It's no longer going to try to land on the moon. So they've changed the process quite a bit. And of course, without the Lunar Gateway, which was the space station around the moon that was proposed to go with Artemis, it's going to be very, very hard to bring back a sustainable exploration system of the kind that was advocated for in Apollo 11 through 17, and they didn't get. So a little bit of history, a little bit of current news, and of course, with the Apollo 11 anniversary coming up this week, I couldn't resist covering it.
Yes. Um, I feel like I read something when I was preparing our notes about Apollo 3, not Apollo 3, Artemis 3. I'd have to go look for it again, but
So
it's
Artemis 3
so-
was going to be a landing, and they changed it
just
to be
recently.
uh in the last year, I think. And this is
Well,
viewers,
I know
please
it
feel
was
free
meant
to
to be the
correct me.
landing. I know it was meant to be the landing with people, and I only looked at it really quickly. But from what I could tell by my like very cursory look at this article, it looked like it was my interpretation was they're going to land an empty thing
So
to
Artemis
test the
3 is
systems.
going to be crewed.
Yes, the crew would stay on the orbiter
Yeah,
and
exactly. And
send the
then
equipment down without crew.
but only in low Earth orbit.
Okay.
So they changed it quite a bit from what they were originally going to do, which is, you've sent craft around the moon, they've sent humans around the moon, but now instead of sending humans to the moon, they're gonna stay around Earth. So it's going to be a low Earth orbit, at least from what I read on the last NASA release. It's still going to be a low Earth orbit set of maneuvers that they're going to test systems with. And I don't think we have a full list of what they're planning on testing, but we do know that it's going to be crewed with 4 astronauts in space. But basically, they want to find out if they can show that they can have any kind of landing system. So, do we currently have any way to land on the moon? No. Will we for Artemis 3? I think that's what they're testing.
Cool. I
Um,
need to do some homework.
Yeah, so it's really interesting, but also it's a little bit, with all the funding cuts that they've had, and all the changes to the program, it's not looking as sustainable as it once was when we had, of course, the Lunar Gateway going up and all this other stuff.
Yeah. Sadly, these things go with political whims and trends and all that jazz.
Yeah, and space exploration is always a risky endeavor. But we do have lots of fun ground-based astronomy that we can always go back to. And perhaps I'll let you tell a little bit about some fun astronomy that we can do from ground-based, because your history sounds really fun.
Yeah. So, my piece of history is a birthday shout out to Chushiro Hayashi, who was a Japanese astrophysicist. Um, the Hayashi tracks on the HR diagram are named after him. We'll talk about those in a minute. He was born in Kyoto on July 25th, 1920, and was one of seven siblings. Uh, his first name translates to loyal fourth son. I always love these translations of names. Hayashi graduated in physics from the University of Tokyo during the Second World War, and then joined the Navy and worked in an optical instrument laboratory. After the war, he returned to his studies, studying elementary particle physics and nuclear astrophysics. He was the first to notice the effects of neutrinos in Gauss's hot universe, and he researched the proton neutron concentration ratio in the early universe, i.e., before the formation of the elements, and wrote papers on possible mechanisms for the large radius of red giant stars, like for how that might come to be. From 1955 to 1965, he worked on nuclear reactions, structure, and evolution of stars. He was the first foreign research associate to be appointed to the NAS, NASA. And he was the first foreign research associate to reside in the Goddard Space Flight Center, and that happened in 1959. So definitely into the run up to our first um, piece of news, um, or history, I should say. At the time, this was a time where non-human computers were just being introduced to the field, and he used this new tech to complete research on the evolution of a 15.6 solar mass star until the end of helium burning with another researcher, R. Cameron. He showed that the red giant branch of star clusters can be properly reproduced if, or the behavior can be properly reproduced if partial ionization of hydrogen is taken into account. And he was building on the work of Fred Hoyle and Schwarzschild on that. Um, the large stellar radii calculated um, occurred when the stellar interior was wholly convective, and this value depended on the luminosity and the star's location on the HR diagram. And so that line on the diagram was named the Hayashi line or the Hayashi limit. And Hayashi proposed that this limit held not only in dying stars, but in newborn stars as well. Um, so in protostars, this would result in flare-ups. And his paper comparing his results to the like HR diagram for cluster GC 2264 was recognized for its importance and was published by the editor of the publications of the Astronomical Society of Japan like right away. They skipped over the refereeing process, which is interesting. And then these flare ups would affect the formation of protoplanets. So his research shifted to the evolution of protostars and the formation of star systems, um, given the time, probably looking at our solar system because we didn't know any exoplanets yet. His work explored the distribution of gas and dust in the solar nebula, the instability of the rotating disk, its fragmentation into planetesimals, the statistical mechanics of collision and coalescence of planetesimals to form protoplanets, leading to the Kyoto model of the origin of the solar system. He was awarded many honors by astronomical institutions and scientific institutions around the world. He retired in 1984, but continued to hold seminars with former students until he was hospitalized for pneumonia in 2010, and he passed away from pneumonia on February 28th, 2010.
What an incredibly accomplished person.
Right? He just studied all the things.
Yeah, yeah. Well, and especially, I mean, this is so fundamental to everything we do in astronomy now. Um, and I mean, he was involved in everything from, evolution of stars to neutrinos and understanding how stars work in this way is so fundamental to our basic, astronomy classes now. And it's to know that it all came from not just one person, but one person's major contributions to what was there. The amount of data that we can now get just from the light of the star increased, well, astronomically, I should say, after he was done with it, because now you could get so much more knowledge of your star than what you would have been able to get before. So you can really characterize it, like how big is it, how hot is it, what does that mean for its evolution, maybe how old is it, right? Where is it going? How do these things work? So cool.
Yep. I always like learning about um, astronomers that I didn't necessarily learn about in school.
Yeah, and I mean, I think a lot of us might have seen the Hayashi tracks and um, not even really processed where they came from originally, because they occur in most astronomical textbooks.
Hmm.
But a lot of times, you know, the Hayashi track will just be sort of absorbed into what are called stellar evolution tracks. You know, isn't this handy?
Yes, that's it, right? I don't recall seeing one where it was labeled Hayashi track. It was just like, and then the star does this. It
Yeah,
moves
and
over
it's
here.
yeah, and you know, in good books we'll probably label them, but a lot of times, you know, some texts are not very good at crediting. Um, and but you know, it's great that the information is out there, and of course, uh, the amount of publications, as you mentioned, he's done everything. Um, then if you were to try to read all of his publications, it would be a serious endeavor because I had a look at some of his works that are like well over 200 pages long.
Yeah. Yes. And there
Uh,
are a lot of them. Like the list just kept going.
yeah, yeah, this is a major contribution to our understanding of the universe, really. And just in so many different areas. I mean, looking at stellar birth, looking at all these things that we need to form planets, looking at nebulae, and yeah, this is somebody who really deserves to be at least given a paragraph next to your stellar evolution tracks.
Indeed. All right, folks, you are listening to York Universe, broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. For chat, questions, content, etc., all the good observatory things, you can always visit our website, www.yorku.ca/science/observatory. This evening, you are listening to Judy Tomei and Dr. Elena Hyde, and we have just wrapped up talking about this week in astronomy and space history. Um, Elena, we have a few reminders.
Yeah, so per usual, this time of year, we do have some news. The observatory York has been busy. So it is summer, which means, of course, we have the fabulous Astronomer in Residence program. And I would be remiss if I did not point out that I do have an Astronomer in Residence in this episode with me. Um,
I leave in a couple of weeks.
exactly. Dark skies await you, I hope. Not cloudy ones.
I am looking forward to it. It's a week earlier than I usually go, so that I can be there when the Perseid meteor shower peaks.
Amazing. And of course, I'm hoping that you do get some aurora. I have seen that there is still actually some chance of recurring aurora, which I thought, you know, it would be dipping down more this year compared to last year, but fingers crossed.
I look forward to it. The aurora, well, my family and I traveled to the Northwest Territories in February to see the aurora, and they were so cool. It'd be great to see them again.
Yeah, exactly. And if anyone does want to follow along, the Astronomer in Residence is running all summer, all the way through sort of September. Sometimes we go into October, but not this year. And we have live blogs on the website. It's yorku.ca/science/observatory. So same website, but you just click on the astronomer in residence or do /air, AIR at the end. There's live blogs from every astronomer who goes up all summer. And of course, if you are out at Killarney Provincial Park, you can join the shows, the live shows at the observatory in the Dark Sky Preserve. And if you're not at the park, we actually have live streams on YouTube. So just like our online public viewing, but live from Killarney Provincial Park. We've had one stream already this summer. It's actually already on the Allan A. Carswell Observatory YouTube channel. So if you check out recent streams, you can actually see what the telescope has seen just two astronomers ago, 3 astronomers ago, 2 astronomers ago. Um, this summer. So we have live views. It's very exciting, lots of fun. Obviously, everyone can join for free in all of these activities, and there's a lot other things going on. So we do have our regular weekly tours. This Wednesday will be an observatory tour on York Keel campus in Toronto. If you would like a free ticket for another one of our fabulous events, they're every Wednesday. All of our weekly events are free thanks to our amazing crew of volunteers. This Wednesday, it will start at about 9 p.m. due to the very late sunset. But the free tickets are on our website, and you can just grab one just to let us know that you're coming. And the reason I mention all this wonderful free stuff is to support our wonderful free stuff. We are doing an Astro Fair. So come to Astro Fair this year. It will return August 29th. Tickets are on that same website. Every ticket purchase goes directly to support our free activities, to pay our students, and sometimes we even repair some of the equipment. Um, anything that can't be fixed with duct tape, for example. Um, so Astrofair will return August 29th, and we're going to be joined by a whole slew of folks. The Astrofair this year, we're going to have some new participants as well as a few sort of blast from the past. This is our second time running Astrofair. This time, we're actually going to be joined by the Nanosatellite Research Laboratory, who are going to
Ooh,
bring a real research satellite for people to play with. We're
amazing.
going to have comets flying through the display. We're bringing back the visible neutrinos, and of course the Astronomy in Action planetariums. And we're bringing in for the first time the 3D printing telescope company, 10 telescopes, and they're going to
Ooh,
bring all kinds of cool three-dimensional stuff. So there's a lot of things coming back, a lot of new things. Our list of partners and everything is up there on the same website that I've been sort of giving everyone all episode. Um, and it's yorku.ca/science/observatory, and then you just click on Astrofair 2026 or do /Astrofair 2026. We're even going to have a little Space Place booth with Kirsten, and Space Place Canada is one of our big planetarium, I suppose, enthusiasts for Toronto.
yeah,
So
we would really love to have a planetarium.
wouldn't it be great?
It would be so great.
Um,
The old one's
and
gone.
I know
Like
it's
it's not but
even
a pile of rubble now.
I know
Like
it's even
it's
more
gone
gone than
gone.
it was before, which is
Yeah.
really unfortunate. Um, but we'll at least have an inflatable planetarium at
Yes.
Astrofair so people
And
can
that
come in,
neutrino thing was so cool.
and it's coming back.
Yeah.
And we're even getting a booth from Soric Screen, which is a Ontario-based company that does high-grade optical screens for example, for telescopes, and they're bringing a light box and an entire interactive display.
So
Um,
cool.
Rask Toronto Center will probably be there, and we might even be able to get a booth from the Barbados Observatory, the Harry Bailey Observatory in Barbados, because one of their astronomers is actually coming as an astronomer in residence.
Oh,
So everything comes first full circle. Lots of news happening. Everyone, check out the
amazing.
website.
Well, it's definitely an exciting summer at the Allan Carswell Observatory.
I know we're gonna have to sleep for like 2 days after the 29th, but that's okay.
It's okay. There's still like a week before school starts
Yeah, yeah, yeah.
after
I
that.
think that's about right. I hope so. Let me check my. I need to
I,
note to self, put something in my calendar to make sure I don't miss the first
pretty
day of
sure that's
classes.
the case.
Yeah,
All
be really,
right, shall we? Sorry?
yes. Let's do some news. Let's do some news.
Let's do some news. All right, Elena. Tell us
Uh,
how mirrors in space are still a bad idea.
they are a good idea if they're telescopes.
Yes.
However, I started off talking about Apollo 11 and kind of um, the news and history behind that, and so I thought I would dive into a news item that's causing a little bit of consternation to um, astronomers today.
Mm-hmm.
It's something that we've talked about a little bit before, but there's a satellite company right now called Reflect Orbital, and it has proposed to put a giant mirror into space. And instead of pointing it at stars and making it a telescope, as astronomers are wont to do, um, they want to point it at Earth, and not in a way of like a geo geosensing satellite or of some sort of archaeology satellite. No,
Just
they
for
actually want.
funsies?
Yeah, they actually just are going to reflect light straight back down onto the surface as much as they can. And the project has some scientific um, problems, in that it's very unclear that their mirrors will do what they say they want to do. And
Mm-hmm.
originally, we talked about this as a potentially very, very damaging project that could really harm plants, animals, telescopes, astronomy of all kinds, and probably humans too. Because if you're disrupting the night cycle of anything, that's we already know that's very, very bad. In large cities, we've seen incredible damage done to ecosystems and animals. And you go out, of course, to the Killarney Provincial Park or some other darkscape preserve, where the circadian rhythms are preserved, and huge, huge benefits to your entire system, and that includes the humans. So we know that putting extra light into your cycle is not necessarily a good thing for plants, animals, or humans as we know it. But if you were to try to shine light directly onto, for example, solar panels here on Earth by reflecting it from the sun back down to solar panels in, for example, areas that were reliant on solar power, could you actually scientifically reflect enough light from the sun back down to Earth to create substantial power for a solar panel? And this is a math problem, and it's not at all clear that the mirror they have will do this.
Is
So
that
they're going to
the
look.
reasoning behind this project?
Well, it was originally. However, it has been proven in the last few days, and this is the recent news, it has very much been proven that they are not going to be able to do this. They are going to be able to create enough light to, for example, disrupt the rhythms of animals and plants and humans, but it's not going to be enough to appreciably power any system.
We
So,
also already do that without going to space.
exactly, we do. That said, despite the fact that it has no set purpose that they're able to really sell, they're still hoping that they'll find people who just want to like buy sunlight to light up their area, which sounds
What?
odd. And somehow they've actually got a satellite ready to launch. And this is the thing, they went ahead and already got FCC, or Federal Communication Commission, permission to launch their demonstration satellite on SpaceX in 2026. This is just one satellite, which is going to be a nuisance, and we can only hope that it fails as fast as the last mirror that attempted to be launched into space for this kind of purpose. But they did say that they want to launch not one, not two, but 50,000 of these into orbit.
50,000?
50,000
50,000
uh,
things to do nothing useful.
with 20-meter mylar reflectors, which would basically cast a moonlight bright spot about 5 kilometers in width,
Well, that's just gross.
which is bad. Um, so there's a lot of things that are very, very bad about this project,
Hmm.
including that it has been approved and will launch its first satellite. But, one thing I do take a little bit of solace from is the fact that I can't, for the life of me, think of any use case for this where anyone would want to do anything other than pay them not to turn it on.
Maybe that's their angle.
Yeah. I mean, astronomers will be very interested in not having it on. If you wanted your backyard to be moonlit bright, how could you possibly afford to pay them after they've spent, they would have to charge millions and millions of dollars per hour to make any kind of cost, I would think.
I'm going to
Unless
tell you
they're
exactly what I would do if I wanted my backyard lit, moonlit bright.
wait until the full moon's out.
Well, that, or I would go to Home Depot and buy one of those really bright lights that my neighbors, when I was growing up, had.
Oh no, those are so
Drove
bright.
me crazy every time I wanted to go out with my telescope.
Oh,
But I
those are
digress.
way brighter than the full moon, I have to say.
Exactly.
They're
Exactly.
way,
And
way
it's
brighter. Those are
cheaper too, I bet.
floodlights. They're floodlights. They're a hazard in and of themselves,
Yeah.
but they are localized at least, so it's not going to be over 5 kilometers.
5 kilometers.
Um,
Oh my goodness.
they also have, and I will say that I do kind of have some thoughts about reflectance and light focus, but they do claim that the light will not be intense enough to start fires or harm eyes. Um,
Mm.
which I have some doubts about because, of course, we've all seen light focus through mirror telescopes or even just with a normal mirror. Um, you know, magnifying glasses setting things on fire, not signs. So the news in this
Yes.
one is very odd. In the sense that I can't imagine how they got the money to launch this satellite because satellites are really, really expensive.
Yes.
So
Um,
it's why would anyone invest in this and what's the real use case? Because if you're not actually able to generate appreciable electricity and you're lighting up a really large area at a very large cost with tremendous environmental effects that are negative, what is the real use case of that? Are you just like Sauron from the Lord of the Rings? Is this,
I'm going to go with yes on that one.
yeah. So, that's the news at the moment. It is still a bad idea, but I take some solace in the fact that these things do tend to be very technically difficult to create, and it's only the first one. So maybe if it just burns up quickly, they won't have enough money to do another one.
Yes, I generally do not root against space projects, but this one,
Yeah, that's
may it burn. All right. Well, now that we are appropriately fired up, uh,
yeah. Speaking of things burning,
stars. Um, So stars similar to the sun end up becoming planetary nebulae. So their cores contract and become white dwarfs, and their outer layers are puffed outward. Before this, however, the star expands significantly into a red giant. And in our solar system's case, the inner planets, possibly including Earth, more on that in a bit, will find themselves engulfed within the sun. Um, don't worry, we are all going to be long gone by then. Um, but why am I talking about this? There is an exoplanet called WD1856b that is a Jupiter-like exoplanet 81 light years away in the constellation Draco that orbits close to a white star. It is larger than its and then the white dwarf, but it's not more massive because white dwarfs are very, very dense. Um, the planet has a mass approximately 8 times that of Jupiter and has a temperature of about 130 degrees Celsius, which is warmer than expected. Um, it orbits its star in 1.4 days, and it's thought to, well, there are a couple of ideas as to how it got to that position. Um, it is of interest because it has survived the death of its star. And there are, some similarities to our solar system, but the system does differ differ significantly in one way, that our solar system has a one star, and this system uh, does have the planet orbiting the white dwarf, but the white dwarf itself is orbiting a pair of red dwarfs that are each about 30% the mass of the sun. So you get some extra gravitational interactions happening there.
That
So
is
the
so
two,
cool.
yeah, um, the two hypotheses of how the planet got to be so close to the star are: one, the planet was just outside the stellar core of the red giant phase. So it was not within the part that condensed to become the white dwarf, and it was in the outer layers that are puffed away. Or the planet was further away when the star was in its red giant phase and then moved inward later due to these gravitational influences of from that red dwarf pair. Um, the discovery of WD 1856b was announced in 2020 and was the first evidence that planets could survive the death of their stars. This star planet pair have now been observed using JWST, and the planet has been found to be mostly hydrogen and helium, but it contains an unusually high amount of methane compared to Jupiter. Its warm temperature um, is attributed to gravitational interactions with the white dwarf as it got closer, if that was the case. Um, the star that became the white dwarf died about 5 billion years ago, and would have been up to twice the mass of the sun when it was in its main sequence days. So, what will things look like in our solar system when the sun's time comes to become a red giant? Mercury and Venus will definitely be within the sun. The planets from Mars outwards will not. So, uh, they won't be within the sun, but when the outer layers of material get puffed away, that would push them further out from their current positions or their current distances from the center of the solar system. As for the Earth, we don't know. It could go either way, depending on just how big the sun gets. But as I mentioned, luckily, none of us will be here. It'll be some alien astronomers watching, going, "Oh, cool, check that out."
Absolutely. Nothing like a nice alien astronomer. They probably didn't have any giant mirrors in their way.
Who knows? Maybe they did, and they got smarter.
That's true. We can always wise up and make smarter choices.
Yes.
Um,
Um, just another example of JWST being amazing.
there are so many examples now, and it's really letting us see things that we really couldn't have seen before. Um, and it's nice to have these kind of really solid astronomical wins happening, especially when there's maybe slightly less good things happening in other areas.
Astronomy will always be good.
It all, and that's the thing is it's done by people who want to see it succeed for the best of reasons. And you know, things like looking at really, really interesting systems. They're very different from ours. Can still tell us a lot about how stars work and how planets work. And this is just such an interesting planet, around these crazy stars.
Sure
Now,
is.
I should probably go and do one more quick news item. I think we have some time.
Yeah, absolutely. Go
I'll
for it.
leave a bit of space for perseverance though, because it's really cool. But one other thing I thought I would cover that's in the news right now. So one thing that's happening with the Reflect orbital is it is being launched aboard a SpaceX rideshare mission, and SpaceX is, of course, the company that is also producing a lot of other sort of space missions, selling their services to NASA. And one of the things they're trying to do is come up with a really heavy lift rocket. So their solution to this was the Starship, which is has not been used. So the SLS was what was used for Artemis 1 and 2. That one seems very solid. It's succeeded spectacularly twice now. But Starship from SpaceX has been really exploding quite a lot. Um, it would be fully reusable if it didn't explode. Um, but it's still not trustworthy. The testing has not gone great. It has some issues in the sense that we still cannot use it as a super heavy lift launch vehicle. So, what other options do we have? Well, NASA has the SLS, which is very, very expensive. But in the news now, there's actually a rival happening from Europe, which we haven't heard a lot about in big space launches recently. And I thought this was kind of
Hmm.
cool. So, you know, if they can get it working, the SpaceX Starship would be really revolutionary in the sense of letting us launch substantial amounts of stuff into space on a single liftoff that would be reused. And the Starship would have the ability to carry 100 tons into low Earth orbit and remain fully reusable. So this would be incredibly powerful and incredibly cost effective if they can get it to work. That's a big if because there's been a lot of it not working, and it's hard to say how close they really are. So Europe has come up with the RLVC5, which is a not a good acronym, but but it's got a very, very different approach. So instead of trying to be fully reusable from the beginning, they're trying to get partial reusability, but like maximum efficiency. So they're
Mm.
using a reusable winged booster from one of their long-running Spaceliner programs that's already working with an expendable upper stage, and they're going to use liquid hydrogen, liquid oxygen propellant, which is a more efficient combination than the methane and oxygen used by Starship. And unlike the Starship, it's not going to have a completely vertical landing, which is, spectacular, but only if it works. So they're going to go back to one of the old classics and glide on wings, which of course we have seen with the old space shuttles with great success. Their plan is a little strange because it's gliding on wings and then it's going to be captured midair by a large subsonic aircraft, which I'm a little bit unsure on.
Oh my.
um, the recovery method sounds probably the most dubious to me of all the things in this particular news item.
Yeah.
But the booster doesn't need to reserve propellant for landing. So you actually save that, and more of its fuel can be devoted to reaching orbit. So you gain in
Hmm.
efficiency there. And of course, Starship weighing 3 times as much as the RLV C5 means that Starship has to lift 3 times as much weight. So only about 40% of the mass that Starship puts into orbit is actually useful payload. The rest is just its own self. The RLVC-5 would actually have 74% of the mass be just the payload, just what it's taking in. So
Wow.
it's much, much, much higher efficiency. So it's really interesting. Of course, the concept versus an actual finished product is another thing. So we're still waiting for some more tests, but I'm really interested to see how far they get with this new RLVC-5, and I think it's very interesting news that they're now working on a solid competitor.
Yeah, something to keep an eye on for sure.
Okay, but now the really, really cool stuff. Let's go to my favorite planet.
All right. Well, we're going to Mars. We're going to visit Perseverance. The rover continues to persevere, pardon the pun, in its exploration of Jezero Crater, an impact basin on Mars' northern hemisphere that once supported a lake. And it's actually left the crater and is like on its edges right now. Um, so the findings of Perseverance are helping scientists better understand Mars's geological past. And a team led by scientists at Imperial College London published a paper recently in the Journal of Geophysical Research, Planets, in which they revealed an ancient feature formed by multiple asteroid impacts. The feature, which they've nicknamed Broom Point, is 75 meters thick and layered bedrock that formed over 4.9 billion years ago. It's some of the oldest rock ever studied by a rover on Mars. So it's bringing insight into the late heavy bombardment era of our solar system. This era spanned 4.1 to 3.8 billion years ago and was a really dynamic and chaotic part of our solar system's history. At the time, there was a higher than average rate of impacts of asteroids and comets with the planets that were forming in the inner solar system. Perseverance, as I mentioned, left the Jezero crater proper in late 2024 and has been exploring the western rim of the crater since. And so these are areas that predate the impact that created the crater. And because Mars doesn't have plate tectonics, that past is much better preserved on Mars than it is on Earth, where rock is going through that rock cycle that we learned about in the fourth grade and changing over time. So 6 different rock types have been found at Broom Point. And they're arranged in layers between angular fragments called breccias and fine grained rock dust. The evidence of cavities formed by gas bubbles in the breccia show that they were once molten. There's also glass beads that have been found that indicate either volcanism or high energy impact. The largest of these beads are comparable to those found at Chicxulub, which is the impact location on Earth that led to the demise of non-avian dinosaurs. Probably the most famous of impacts on our planet. The layering of the rocks indicated multiple high energy impacts. Some layers are tilted at more than 80 degrees, which is too steep to have been caused by the impact that formed Jezero crater. So there would have been a previous impact that was, more energetic to really tilt those rocks in that way. The layers record impacts of different sizes that happen at different distances from the location of the formation. The debris gathered in this spot and recorded those events in the rock. There's also some evidence for interaction with water or ice. And so this area of Mars, as well as similar basins on the moon and Mercury, are providing important clues about the early days of our solar system that we don't have that evidence for on Earth because of our plate tectonics, and it's helping us develop a timeline of that part of the history of the formation of our solar system.
So fun. And of course, Mars being full of discoveries and news is no surprise to me because it just, every time we go look at it, we find out something new. And Perseverance running around still today. It's just too bad Ingenuity wasn't there. Its little helicopter could fly over
Yeah.
and get us more panoramas. But this is just another one of those great missions that has just kept going and going and going since, 2020.
I love a good mission that keeps going and going and going.
Exactly. And it's still going and discovering new things and finding out more about the past. And these really old rocks are interesting because we've seen so many interesting compounds and tantalizing clues for what might have been there in the early solar system. And it really just is like, oh, we're just gonna have to go there and walk around at some point. But this is a really fun one.
Yes. Well, we will keep an eye on Mars. Um, but that is the time that we have for this evening. So, everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde and myself, Junie Tomei. You can connect with us on socials or go over to our website, yorku.ca/science/observatory. Thanks for tuning in to York Universe, clear skies, and have a good night.
Thanks, everyone. Mars will be up around 3 a.m. Have a good night.